It's a great pleasure to see you all here. Let me say a few words about KAIST. KAIST was established in 1971. That's the year the government of Korea more or less decided to emphasize heavy industries such as shipbuilding, automobiles, steel making, what have you. When they decided to industrialize in heavy industries, they realized that they do need people with advanced education, people with master's and PhD degrees, which Korea was not producing at the time. So they decided to start a new university rather than giving the grant to existing university. This is how KAIST was born now 39 years ago. Since then, KAIST has achieved its intended goal. KAIST has produced a large number of PhDs and master's degree people, and later on, people with bachelor's degree as well. For instance, today, 25% of Samsung Electronics PhDs are KAIST graduates. More than 10% of all professors in science and engineering in Korea are KAIST graduates. And our graduates are now professors at MIT and elsewhere. So indeed, KAIST has achieved what it was supposed to be doing when they created the institution. Today, KAIST ranks very high in the world ranking, if you believe in that. In engineering and IT, we ranked 21 in the world, which is not too bad for a relatively new institution. So what makes KAIST so great is the quality of people. We have outstanding students, faculty, and that indeed is the resource we have at KAIST. It's a state-funded institution. Everything is paid for more or less by government. In some ways, the analogous or similar institution in the United States would be MIT. There are many similarities between our two institutions. And RPI, I think, is similar as well. What I'd like to talk to you about today is one of the projects we started in 2009 when Korean government decided to create a supplementary budget to hire people and so forth. We convinced government to undertake major projects, so indeed scientists and engineers could be hired as well. So since we're emphasizing what we call EWS, energy, environment, water, and sustainability, we asked government to fund us so we can solve some of these major problems and then help humanity in the 21st century. One of the problems that all of you are aware of is the generation or emission of CO2 by automobiles. One way of getting rid of CO2, obviously, is not to use internal combustion engines. So one of the approaches to it is to use electric batteries. So a large number of companies and governments throughout the world are working on electric cars to eliminate CO2, which is causing global warming, among other things. So what we have done here is to ask ourselves how we can use electricity to propel vehicles. And when we asked that question, the answer was that using batteries and carrying the energy on board in cars by having large battery is not a very efficient way of doing this. As you know, batteries are very expensive because they are lithium-ion based or lithium polymer-based batteries. They're heavy, expensive, and big. So when you buy cars with these kind of lithium-ion batteries, they're very, very expensive. A car that you would pay $20,000 for gasoline-powered cars, you end up paying $40,000 or more. So we didn't think that's the way to go. So our idea is very simple. Our idea is to only put in a very small battery, and then it will enable the car to go from wherever they are to a road with underground cable. So we supply energy through this underground cable. So we put this cable under the ground, and the power is generated. It goes to the pickup unit, in this case on the bus, without any wire. It's a wireless transmission of very large amount of electric power. Right now we're transmitting somewhere around 64, 65 kilowatts, and we can go up to 100 kilowatts and so forth without any problem. And the volume taken by our batteries being so small, it takes up only small floor space of small portions of the vehicle, whereas all battery-driven cars will take almost every space you can think of so that you can store the batteries in there. So we had built this thing in a very relatively short period of time, and we actually installed this system. Our thinking is that if we use this system, then if we build 2 nuclear power plants, 1.5 gigawatts each, then Korea does not have to import any oil at all. That means Korea can save about $30 billion of oil it currently imports to propel all the vehicles. There are 13 million cars in Korea, I understand. And then we can use electricity coming out of 2 nuclear power plants. That's what we plan to do. We built many vehicles. We built buses, small SUVs, and whatnot to demonstrate our concept. And we installed this one in Grand Park of Seoul City. This is a park where there are amusement parks and whatnot. And then we embedded this in underground. And the total length of the perimeter is 2.2 kilometers. But the length of the underground cable is only about 360 meters, because we don't have to have everywhere. On the road without this underground cable, we draw power from battery. When it goes on the top of this thing, we recharge the battery. So there's no consumption of energy from battery when it goes around once. Lots of people rode on this thing. President of Israel was on it. Prime Minister of Denmark was on it. President of Korea obviously was on it. These 2 things you see here are sports cars built by our students based on the same concept. And it's a very powerful concept. Most people really did not understand how we do this, and only recently we could disclose the basic principles that enable us to achieve this kind of feat. We hope to extend this to taxis, buses, high-speed trains, and so on and so forth. The efficiency of power transfer is very high, 85%. We think we're going to go up to over 90%. In the case of train, we think we're going to reach about 96%. And the economy of this kind of system is much better than the cost of using gasoline or something else. Indeed, according to our calculation, it will cost about 20% for installation relative to the cost of having all battery system, and 20% relative to using gasoline as a mode of the power supply. So this is what we do. Thank you.